Welcome back to the deep dive. Today we're jumping into climate change and biodiversity, a huge topic, obviously. But we've got some brand new research that might actually flip some common assumptions.
Yeah, our deep dive today comes from some really cutting-edge work looking at climate adaptation in, well, dragonflies, believe it or not.
That's right. And our mission today, really, is to unpack how these findings challenge the way we thought about when climate impacts hit species hardest and, where those impacts really matter for conservation.
Okay, so let's get into it. For a long time, I think, when we looked at climate impacts, especially for insects, the focus was kind of naturally on the adults, wasn't it? I mean, they're the ones flying around, they're visible, easier to track, presumably.
Exactly. They're just easier to observe their size, movement.
But this new research, it throws a bit of a curveball there. What was the core finding about these dragonflies that was so unexpected? Well, it's quite something. Basically, they found that the climate conditions the dragonfly nymphs experience underwater, that's their juvenile stage, right, in ponds and streams.
Right. Before they're adults.
Yes. Those underwater conditions actually have a stronger influence on the traits of the adult dragonfly later on, compared to the conditions the adults face on land.
Wow. Okay, so it really shifts the focus from the air back down into the water.
It really does.
That's fascinating. So it's not just what we see buzzing around, but this hidden underwater phase is critical. Like, finding out an athlete's performance is dictated more by their early training than their final prep.
That's a great analogy, actually. And it's significant for how we think about biodiversity itself.
How so? Can you expand on that?
Sure. So biodiversity isn't just the count of different species, right? It's also about the variety within those species, differences in body size, shape, maybe even behavior.
Okay.
And for ages, our understanding of how climate change affects that diversity was, well, mostly based on looking at the adults because, like you said, they're easier to study.
Uh-huh.
But this research shows those early stages are fundamentally shaping the adult traits and, therefore shaping how the species as a whole might adapt or struggle.
Right, that makes sense. It really makes you reconsider things. So how did they actually figure this out? I mean, measuring effects from a hidden underwater stage across, many species, how did they manage that?
Yeah, the methodology is pretty neat. The researchers developed what they call a statistical framework. It's basically a smart way to measure how much those early life conditions contribute to the diversity you see in adult traits.
Okay, a statistical model.
Exactly. And they didn't just look at one or two types. They analyzed data from, get this, 87 different dragonfly species across Europe. It's a huge data set.
87 species. Wow.
Yeah, and they compared climate data, landscape info, habitat details with the traits they measured in both the aquatic nymphs and the flying adults.
So comparing the before and after, essentially.
Precisely. And what emerged were these really strong carryover effects, showing that what happens underwater significantly carries over into the adult stage. It's not just a holding pattern, it's actively shaping them.
Okay, carryover effects. That's the key term. That's a big step forward methodologically. So what does this mean, practically, for conservation? If we've mostly been looking at adults, this changes things, doesn't it?
Oh, fundamentally.
Yeah.
It strongly suggests that our climate adaptation strategies can't just focus on adult populations. We absolutely need to consider the conditions species face much earlier in their lives.
Right.
Professor Lars Iverson, who led this study, put it quite well. He said these results will provide a new general rule to guide how biodiversity scientists forecast climate responses.
A new general rule? That's quite a statement.
It is. And another author, Leslie Lancaster, added something important too. She pointed out that, many predictions are based on observations of adult stages. But their work shows the observed climate impacts are actually largely indirect consequences of processes affecting juveniles.
So the impacts we see in adults might actually be echoes from their youth, so to speak.
Exactly. We need to adjust our focus, potentially look deeper into those earlier life stages.
This feels really practical then. It gives scientists and policymakers actual data to help decide, should we focus conservation efforts on the young ones or the adults or both?
Precisely. It helps target where interventions might be most effective for climate adaptation or mitigation.
So wrapping this up then, the big takeaway for you listening is that understanding these often unseen early life influences is, absolutely vital for protecting biodiversity effectively as the climate changes. We need to look beyond the obvious stage.
And it leaves you with a thought, doesn't it? What other species out there might have these crucial, maybe overlooked early stages that are key to their survival and adaptation? This dragonfly study really challenges us, I think, to broaden our view on conservation, to consider the whole life story of a species, not just the final chapter we most easily observe.